I took a break.
Don't stop it, because I want it all in one piece. When I mean take a break, okay, we're starting over.
Starting over.
Yeah, I got to start over.
Blooper reel.
All right, so we're going to solve this equation with the inverse matrix. So let's take this matrix and we're going to rewrite it in this form: A times X equals B. All right, so let's talk about what is A. A is going to be the matrix we get with the coefficients. Okay? The X matrix is going to be your variables. And the B matrix is going to be your solution to the equations. Okay? So, matrix A. What are the coefficients in the original problem? 3 for the X, first X. -1 for the Y. 2 and 7. Okay. The X matrix is going to be one column. Okay. And what is the variables? X and Y. So we're going to go X and Y. And what does that equal? What's the solution matrix? Or what's the solution to the equations?
14 and -6.
14 and -6. So this is matrix A, this is matrix X, and this is matrix B. Now, this seems weird that we would write this, right? But do the matrix, what are we doing to matrix A and X? What are we doing to them? Multiplying them, right? So take the rows of A, use the column of B, and to get the 1, 1 spot, talk to me. What would that be if you did matrix multiplication? 3x plus -y equals what? Boom. Okay? What would this one be? 2x plus 7y equals -6. So all this is the other way of writing this equation with matrices. Okay? Clear?
Yeah.
All right. Now, find A inverse. Yesterday you learned how to find A inverse, right? So, A inverse equals, what'd you do yesterday to find A inverse? So let me rewrite A. So A equals 3, -1, 2, 7. Okay, so to find A inverse, what'd you do?
1 divided by
You're going to get the scalar 1 divided by
3 times 7
3 times 7
minus 2 times -1.
minus 2 times -1. Okay, so what's that going to, and then we're going to multiply that by, we're kissing each other.
7.
Switch the 7 and the 3, right? Switch those.
One and
And multiply these by -1. 1, -2. Beautiful. All right. So what do we get here? 1 over what? 1 over 21 minus -2, or it's 23. So that's the scalar that we're going to multiply by 7, 1, -2, and 3. So what's A inverse?
7 23rds, 1 23rd, -2 23rds, 3 23rds.
Beautiful. Okay, so that's A inverse. That's what we did yesterday. Now, we're actually going to use this inverse to solve this equation. All right? We're going to use this inverse to solve this equation. Coach, can we come over here? All right. We still good on the vision? All right. So, what we know right now is we have A times X equals B. That's what we wrote in equation A. A times X equals B. And what are we really trying to solve for when I say solve this system of equations? What are we really trying to find? X and Y. So what matrix are we trying to solve for? X. So we want to get this by itself. Okay, is there matrix division? No, so we can't divide by matrix A. But how can we kill matrix A basically? How can we get rid of it? Multiply it by A inverse. So if we take A inverse times matrix A times X equals, so over here we'll have to take A inverse times B. What's A inverse times A? Kind of 1. What do we call it? We don't call it 1. We call it the identity. And what's the identity times X? The identity matrix times X is just X. So X will equal A inverse times B. You want to know this formula. X equals A inverse times B. X is the variables you're looking for. A inverse is A's inverse, the coefficients inverse, and B, what was B with a B matrix again?
Solutions.
The solutions. Okay, so let's solve this, all right? So let's solve this. So for matrix X, which was equal to XY, we're going to get that X equals, what was A inverse?
7 23rds, 1 23rds, negative 2 23rds, and 3 23rds.
What was matrix B?
14, negative 6.
Okay, what size matrix is A inverse?
2,
2 by 2. What size matrix is B? 2 by 1. So we're going to get this, and what are we going to get? We can multiply because those are equal, and what are we going to get back?
2 by 1.
A 2 by 1. Okay, so we're going to get a 2 by 1 back. So when we multiply, we take the rows of the first term times the column of the second term. So, got a little ugly math with the fractions, but what are we going to get? We're going to get
98.
7 23rds times 14 plus 1 23rds times negative 6. And then negative 2 23rds times 14 plus 3 23rds times negative 6. Okay, so what's that going to equal?
98 23rds, negative 6 23rds.
So what's that equal? 92 23rds?
Yeah.
92
23rds.
23rds and
40, negative 46 23rds.
negative 46 23rds. Okay, what is 92 23rds? 4 and negative 46 23rds? Negative 2. So what did the 4 represent? Can you get me in both shots? Whoop! And what did the y represent? Okay, so what's the solution to this?
4 negative 2.
4 negative 2. Okay, you don't need to follow me. So check that in the original. 3 times, whoa, that's ugly. Got you back on the original. 3 times 4 is 12, minus negative 2 or plus 2 is 14. Okay. All right, so before we start the back page, we're going to give Coach a break. Here, let's see this, Coach. Don't stop it. Okay, we want to thank Coach Kincaid for the outstanding film work. We want to give a shout out to the students that are actually here today who are not taking the AP exam. We are wishing the APers best of luck. Hope they're dominating. Okay, you ready? You ready to go? Have you had a good break?
Good break.
Okay.
Pumped.
Now, how many of you think that is easier than elimination? Nobody, right? Nobody. Okay, so what could be a benefit of this method? Because you got to look for the positive. So what, anybody come up with a benefit of this method? And I told you all along, a lot of these methods with matrices are not easier than substitution or elimination.
The numbers don't have a, maybe a big number, common factor.
Say that again?
Numbers don't have a common factor.
Like an easy common.
I don't even know what that means.
They don't have a common
I
factor.
don't even know what that means.
They don't have a common factor.
Okay, look at A and B here. What do you notice about problems A and B?
They're very similar.
They have like this.
They'd have the same, in matrix terms, they'd have the same A, right?
Yeah.
So if I gave you 10 systems of equations problems, and they all have the same A, and they all had different solutions, you could find one A inverse and just multiply them by all the solutions instead of doing the elimination method 10 times. Okay? So that is, I found a benefit. I found a positive of this method. All right? So, what I want you guys to do here is tell me what A is.
Is it about 3x minus 2y?
3, negative
No, just A.
Okay.
Just A. Matrix A.
3, negative 2, 1, and 3.
Okay? I want you to find A inverse. Go ahead and do that. Switching the DNA did nothing. So what are we getting here? 1/11th? Is that right? 1/11th?
Yeah.
So are you getting 3/11ths, 2/11ths, -1/11th, 3/11ths?
Yep.
What is so funny?
311. 311. Sorry.
Character, coach, your character. All right, so what are we going to have to do to A to solve this solution? To problem A, to letter A.
By negative 27.
Multiply what?
A times the B matrix.
So the solution X equals the A inverse matrix times the B matrix. Okay? So A inverse is the 3/11ths, 2/11ths, -1/11ths, and 3/11ths times what's B?
Negative 27.
2713. And over here, same A, so it's the same A inverse, 3/11ths, 2/11ths, -1/11ths, and 3/11ths times matrix B. On both of these, you're going to get a 1 by 2. This will be your X, this will be your Y. This will be your X, this will be your Y. Okay? So that's just matrix multiplication. Take the rows, multiply by the column. Take the rows, multiply by the column. So I'll go ahead and do the work up here while you guys do the work. And what are we getting?
First one's negative 5 and 6. Second one's negative 4 and 2.
That would be correct. So, check your answer. 3 times -5 is -15. Minus 2 times 6 is -12. So -15 minus 12 is -27. Rock on. 3 times -4 is -12. Minus 2 times 2 is 4, so negative 12 minus 4 is minus 16. We are geniuses.
Genius.
Got it?
Yeah.
Pretty simple, right? Okay. You're doing great, Coach. You're doing great. Just like our U.S. History AP examiners are doing right now. Great. Okay, we're going to do a little test for Mitch. Hey, Mitch,
Oh.
are you really watching this?
No. Yes.
Okay? On Monday, the question's going to be, come up with a question we can ask him on Monday that is a weird question that he'll have to answer. What time was it when I asked if Mitch is watching this? Okay. Now don't give him any hint that we're doing this.
Yep.
All right. Okay, last problem. Coach, you okay? Can you handle one more problem? All right. So this is a 3 equation, 3 unknown. All right. We did not. I've given you the inverse. When we get done with this, though, we're going to see if we can find it. All right. But I've given you the inverse. I do want you guys to be able to do the adjoining method and find the 3 by 3 inverse. So first of all, what would A be in this problem? Chloe, what do you think? What would the A matrix be?
1, 1, 1, 3, 5, 4, 3, 6, 5.
And the X matrix? It's just your variables. So, and you're just going to do them in one column. And your B matrix,
0, 0.
just your solution. Okay? So, does everybody see that this is the same as this? Okay. All right. So, I'm telling you that I did the adjoining method last night while at home for a good time. Actually, I'm lying. I found this problem and just looked up the answer. So, but go ahead and take this. If this is A inverse, how are we going to find X?
A inverse times B.
A inverse, all these numbers, times the solution matrix, or the solution matrix, 0, 5, and 2. So now we've got a 3 by 3 times a 3 by 1, so we can multiply and we will get the 3 by 1 back. The 3 by 1 will be the x, y, and the z solution. Underline your rows, circle your column. Okay? Left, right. Top to bottom. 0 plus 5 plus negative 2. 0 plus 10 plus negative 2. 0 minus 15 plus 4. 3, 8, negative 11.
8.
Is 3 plus 8 plus negative 11 0?
Yep.
Are you impressed, Coach?
Quite.
Have you ever done this?
I don't know.
All right.
At some point.
Great class. Thank you to Coach Kincaid once again. Appreciate it.